So just for a little refresher, we have the foliational completion of the cube x, and right, it's defined as the union over the diagonals. So that means we're getting 4 total copies of these foliations. So we have not just one foliation, but 2, 3, 4. Then we sum over basically the infinite set of parameters. So basically the leaves are like diffeomorphic to this sphere Cartesian product with the open unit interval. And then if we're including the diagonals, the 4 diagonal lines in the cube, then we have to say we have to include we basically have to take these codimension 1 leaves, which constitute most of the leaves in our foliation or foliational completion, and we also have to if we include the diagonals, we just include 4 codimension 2 leaves. So these are in some sense like singular, because the leaves here are collapsing to like a single line, and they represent like singular leaves in our model. So it's not a regular foliation. It wouldn't be like regular foliations in this case. It'd be a non-regular foliation. I know this kind of looks confusing here, but so we basically want to view this tuple as our fundamental sort of objects. In dimension 3, if n equals 3 here, then recall that we can get a nice subspace, which sort of looks like this. And remember, that's MathCal hour, the interface construction. So when I say these are fundamental objects, I just mean we have like a space and we have a symmetry group. This PI, the piecewise isometry group of MathCal I, which is just slicing along halfway coordinate planes, slicing it in half, and then turning pieces like a Rubik's cube. And that's why we get the 2x2 Rubik's cube group as a result. Also recall that we can get a graph, a gamma set, which is just the intersection locus of the coordinate slicing planes. So when we slice by a plane, we're going to get an intersection locus, which once unioned over all coordinate planes gives us the gamma set. The spectral tower indexes all our F completions. The goal is to use each one to populate a space. So this one would correspond to point.